Well, in 3.1 and 3.2, we learned to graph a system of equations. Now we're going to learn in 3.3 how to graph a system of inequalities. So we're just switching your mindset from equations, which would just be a solid line or a dotted line, or if you have absolute value equations, then you would have your v'd line, whether it's dotted or solid. We're switching from that into a system of inequalities. So this changes nothing except for the fact that now we're going to have to deal with some shading, and we're going to look for the common solutions to these systems of inequalities in that shaded region. And 1 through 3, they asked you to match the system of inequalities with the appropriate graph. We've done this exercise before. I've already solved each of those systems of inequalities for y. So you can pause the video and try that yourself, and then come back and check your work with mine. And now, after we've done all that and we have it solved for y, then we can go in and start doing some reasoning to be able to eliminate some of these graphs for each of these sets of inequalities. If you look at that first set of inequalities and you look at the signs on them, the inequality signs, you can see that we've got a greater than sign for the top one, that red one, and then a greater than or equal to for the second line. So we're looking for shaded things, shaded areas that are above both of the lines. One of them is going to be dotted. That red one is going to require a dotted line, and then the blue one will require a solid line. In the second system of equations, they're both less than signs. Okay, so we're looking for a shaded regions where they're both shaded underneath the line, and they're also less than. So we're looking for two dotted lines. And then in that last system of equations, you've got one less than or equal to, so that's going to be solid, and then you've got that second equation, which is a greater than. If you look at C, that graph for C, you've got two dotted lines. So right away you can see that this second system of equations is going to go with the graph for C. Okay, so we can go ahead and match that one with C. I'll just write it in here as well. So this goes with the graph of C because we have two less than signs and no equal, and that's the only graph that shows two dotted lines. The other two are a little bit more challenging because you have one of each. So then we really need to look at the shading. On number 1, we have a greater than, and number 2 here, equation for that, we have a greater than or equal to. If we look up here at this right here, here is the dotted line that would represent either a greater than or a less than. And you can see that it is shaded above that line, and also that this line has a positive slope. So if you look here at this first equation in this system, this one is a greater than equation, but it has negative slope. So we know that this cannot go with that line. So let's look over here at B. On this side, there's your greater than. So it's solid. I'm sorry, it's dotted, which is what we're looking for. We're looking for shaded above. And we're looking for negative slope because the slope here is -1. So this one is looking promising because number 1 matches up with that. Just to double check ourselves, we can check the blue line. So the blue line, we're looking for greater than or equal to. So that would be this line here, and it is solid. It is shaded above. We're looking for positive slope, a positive slope of 2/3. And we're looking for a y-intercept of -2, which we can see right here. So that's pretty clear that 1 is going to match with B. All right, which leaves us with 3 as A, and we'll just double check with that just to make sure we didn't make any mistakes. So we're expecting a less than or equal to and a greater than, which we have. The less than or equal to, this solid one, we're expecting negative slope. Right here we've got a -1, and that's what we see. We're expecting a y-intercept of 1. We see that there, and it is definitely shaded underneath. If you check the blue line, it's dotted. We're expecting a y-intercept of -2, and we're expecting positive slope and a shading above. And so that does check out that when that system of equations for A matches, I'm sorry, that system of equations over here in number 3 matches with the graph of A. All right, if we move down to number 4, they're wanting us to graph that system of inequalities ourselves. So we'll go to x is greater than -1. We only have one variable in that equation, so that lets you know you're either going to have a horizontal or a vertical line. In this case, because it's an x of -1, all x's are -1, so we're going to end up drawing that line down through -1, and actually that should be dotted because it's not equal to. Okay, and I'm just going to keep in mind that this is greater than, so I know I'm going to be shading over here on the right hand side. I'm not going to do it yet because I want to get that other equation in there as well. And then the y is greater than -1, so I only have a y variable. I do not have an x, so we know we're just dealing with a a horizontal line in this case because it's y of -1. So I'm going to come to -1. Every y is going to be -1. Dotted because it's greater than, no equal to. And so now I can go back in and do my shading. So I'm looking for greater than the x line. I'm looking for greater than the y line. So that's the blue, and so we're going to come up above. We only want to shade what is common to both. So that means I need to stay above the blue line and to the right of the red line. Of course, for the blue line, if it were just the blue line that we were shading for, we would go over here and shade as well. But that would not satisfy the red line because the red line requires us to stay on this side. Same thing for the red line. If we just had the red line and we're shading, then that would go down into this underneath the blue line here. But we've got to keep in mind that it has to satisfy both of the equations. I'm sorry, both of the inequalities. In order for it to be a solution. So that's only this section right here that is going to give solutions that are common to both of them. All right, looking at number 9, we need to take this first equation right here and solve it for y. So I'm not going to show all that math to do that. This is what you would have in the end. And then the second equation is already solved for. So we'll graph that one in blue. This one's a little more challenging because you can see you've got a linear line and an absolute value inequality. So we're going to have to take care of both of those. Let's start with that linear line. And we've got a y-intercept of 5, 2, 3, 4, 5. And we've got a slope of -2. And then connect your lines. It's going to be solid. And we're going to go back and do our absolute value. So if we have that, remember this is our formula for absolute value, where h and k are going to be the vertex. So we can look in here, it is written as a difference, x minus 1, which is what we want. So we're going to pull the h out. Our vertex is 1. Our k is not recorded, so we know it's 0. So we go to 1, 0. And then from here, because it's absolute value, we're going to use this slope, which is a +2. We're going to go up 2 and to the right 1. We're going to remember that this is not a linear line. This is an absolute value, so we've got to think about there being like a mirror right in here running through the vertex. So we're going to mirror this point over that, and we'll get this point over here. This is only greater than, so we're going to have a dotted line. And now we can deal with our shading. All right, this is probably the challenging part. Number 1, the red, we have less than or equal to. So less than is going to be everything under the red line. Okay, so if we were just graphing, or just graphing this inequality, we could color all of this in. But we've got to keep in mind what's going to satisfy for a solution to blue. Blue says greater than this absolute value. So for blue, if we were just doing blue, we would be shading inside that V. But up here isn't going to satisfy for solutions for the red. So we've got to keep it under the red, but over the blue line. So it would just be this little section in here that would actually be solutions for both of those inequalities. 19, we need to write a system of inequalities that represents the graph. So now instead of us graphing the inequalities, they want us to write them. So let's start with the horizontal line. Okay, it's horizontal, so we know it's only going to have one variable. It's running through y, the y-axis. So that's how we know that y is the variable that we're writing an equation for. It is dotted, so we're not going to have an equal sign. And if you look, you can see that the shading is underneath it. So we know that y is going to be less than, and whatever this is, 1, 2, 3, 4, y is less than 4. All right, so that one a little more straightforward than the absolute value. So for 2, let's do that absolute value. So we know that we need a slope. So we need to know what our a is to write this equation, and we also need to know what our vertex is. So that's where you start with this. Let's get that vertex first, which is right here. So we know that's at 1, 1. And then our slope, you're just going to find another point that is on that line and count up and over. So up 1 over 1, so our slope is 1. We can see the shading. The shading is above the v, so that means that we're going to end up with a y that is greater than. It's solid, so it's going to be greater than or equal to. Our a, if we write the formula up here, that might help us just fill in all those numbers in the correct spot. Our a is 1, so I'm going to record it just to show you, just so we don't forget about it, but we'll take it out in the end. X is going to be rewritten. We have a vertex of 1 for our x, that's our x coordinate, and then our y coordinate is also 1, so plus 1. And then if I take the a out, since we really don't need that, we assume it to be 1, then we can leave it like that. So there are our two equations for this diagram. All right, number 20 and 21. During a family trip, you share the driving with your dad. At most, you are allowed to drive for 3 hours. So this is your max that you can drive, no more than 3. While driving, your maximum speed is 55 miles per hour, so you can't go any faster than that. Those are your two limitations. They want you to write a system of inequalities describing the possible number of hours t and distance d you may have driven. So this is a system of inequalities. So right there, that lets you know you need two different inequalities. That makes this a whole lot easier. You're not going to be writing an inequality that has t and d in the same inequality. You're writing a separate one for t and a separate one for d, and your clue there is you're writing a system of inequalities. So let's start with t. They told you that you are not going to be allowed to drive for more than 3 hours. At most, that's what that means up here in the problem. So at most, you are driving 3 hours. So the first inequality is going to relate these two values. The time you drive, t, has to be less than or it can equal 3 hours. You can drive 3 hours, just not more. We'll do the same thing for d. All right, so the d distance, you are limited by 55 miles per hour. Okay, so you're limited to 55 miles per hour. We're going to deal with that per hour in a second here. Your distance is going to be less than or equal to this value over here. So now if we left it like this would just be your rate, your miles per hour. But here's how we're going to pull it all together. If you take your 55 miles and you multiply it by how long you drive, which they told you here was t, then you know you're gonna find out how far you drove. So if you drive 55 miles per hour for 2 hours, then you drove 110 miles total. So that's how we're going to pull these two together. These are your two inequalities. And if you graphed those, you know that you would have this would be a vertical line, all right, at t of 3. And this would be a line that's got a positive slope of 55. It's direct variation, so it'll run through the origin. So you can sort of hopefully envision that a little bit, even though they're not asking you to graph it because you don't need it to solve 21. But if you did graph it, that's what you would see. So this is what it would look like on a graph if you were to graph it. I just want you to be able to visualize it. T, you can tell from this equation here, T is your independent variable, D is your dependent. That's how I knew to put D on the y-axis and T on the horizontal. And so these are the two graphed together. If you wanted to find the common solution to them, then you would need to shade less than 3 or less than that 55t. All right, so it would be all these values in here would be appropriate values for you when you were driving. We don't take the lines down into the negative because we're not going to have negative distance or negative time. Is it possible for you to have driven 160 miles? So you could read it from the graph. If you had a graph that was to scale and on graph paper, you'd be able to read it, but you don't need to because you can just take this 160 miles and plug it in for D in that equation right there. So we can say 160 is less than or equal to 55t. We'll solve for t, and we get a t of 2.9. Well, t is your hours, how long you drove. So if you only drove 2.9 hours, then you stayed within this limit here, this 3-hour limit. So the answer is yes. Yes, it would be possible for you to have driven that long. If you drove that long, then your point would be on the graph would be an x of 2.9, or in this case a t of 2.9, and a d of 160. And so if you found that on the graph, it would definitely lie within this shaded area, and it would be towards the upper region because you're kind of almost to the max of your time allowed. So it would be up in the upper region of that shaded area.